Hi there, it's Iseto. I'm here to show you a cool trick that I discovered myself on how to draw a perfect pentagon using Fibonacci numbers. And I haven't found this anywhere else. I tried looking for it to see if I was just going to make a repeat video of someone else's discovery, and I really have not found this anywhere else. So, I don't know what anybody really knows about the Fibonacci sequence and the golden ratio, but the Pentagon inscribes the phi ratio everywhere inside of it, especially if you do the diagonals of a pentagon. So that long line in proportion to that short line is going to be like this. It's going to be, this is 1 and this is 0.618. And so this ratio is found in nature. It's found in the way that flower petals distribute themselves, sunflower seeds, everything like that. Now, people can argue that it's found in less places than it really is, but that's such a debate. It's such a debate. It's like people don't know how to view the proportion in the correct way. You can proportion things so differently. You can see things so differently. You just have to have the eyes to see it like that. But, okay. 2 plus 3 equals 5. 5 plus 3 equals 8. 8 plus 5 equals 13. 13 plus 8 equals 21. When these numbers are divided by one another, you get progressively closer to 0.618. Especially when you get bigger and bigger and bigger and bigger. Now, if you were to build a pentagon with these numbers are already encoding phi ratio. And the pentagon is a phi ratio construction. I don't really have the visual here to show you every single proportion, but this right here is starting at 5. This goes up 8. This goes diagonally 8. So from the center to the point and the point to the diagonal are supposed to be exactly the same. So that means that I can draw a golden triangle, right? Let's see. I'm holding a phone and trying to draw. Let's see. So that triangle right there is that golden proportion. Meaning this is at phi ratio to this line right here. So if you were to do 5 to the side, 8 up, 8 diagonal, you'd have to do 8 diagonal here, 8 diagonal here. All you really have to do is count to 5, split the 5, go up 8, make a point. At the 5th point, right there, because this whole thing is at phi ratio, at 5 up, you start counting 8 from the center. So when you go out, that's going to be 1. Then when you go out, this is going to be 3. Then when you go out, this is going to be 5. Then when you go out, this is going to be 7. And then half of a cube is going to be 8, because you're going out on both sides. And you're trying to count for the side going out at the same time going this way. So this is also 8 that way. And you're able to build a perfect pentagon. This doesn't look perfect because I hand drew it, but the points are at phi ratio to one another. That's the most important thing. If you had a straight edge, you could make this look perfect. That's how you draw a perfect pentagon, using the Fibonacci numbers, which this is 5. This is 8. Right here, this is going to be 3. Ignore this little point right here. This is going to be 5. If you just consider this. The reason this point is here is because this proportion will split this phi ratio right at a specific point, which makes this little point 2 and this 3. 2 and 3 are Fibonacci numbers. So the phi ratio is a way of scaling up without losing the value of the actual structure. You can maintain it in proportion to a smaller object if it's at phi ratio. So, thanks for watching. That's how you draw a perfect pentagon.